So the last objective is to identify the reference angles of any angle. So the definition is it's the measure between the terminal side and the x-axis. So all reference angles are less than 90 degrees, or if we're in radians, it's going to be less than pi over 2. So let's go ahead and look at the xy axis and identify rules for every quadrant. So if you have an angle that's in the first quadrant, this is going to be the easiest case, because in this case, the reference angle, which is a measurement from the x-axis, so this is the angle at the x-axis, to the terminal side, it is exactly equal to the angle. So in this case, there's no work to be done, right? It's equal. Theta is equal to the reference angle. But once we get into the second quadrant, then things are going to change a little bit. So in the second quadrant, let's draw our angle. It's going to be somewhere there. The reference angle in this case is going to be the angle measurement from the x-axis to that angle. So since it has to be less than 90 degrees, then I have to start with the angle that is closer to the 180. So this is the measurement that I want. All right, I want that measurement from here to here. This is going to be the reference angle. So the way we're going to do it is, if we notice both of these angles, theta and the reference angle, are equal to 180. So if they both add up to 180, the way I can solve for theta r is I can just do 180 minus my theta. Now if I end up in the third quadrant, all right, let's say I have an angle that ends up in the third quadrant, then I'm going to want to find the distance between the x-axis and that terminal side. So now I'm looking for this distance right there. So the way I'm going to find this reference angle is, I know that this angle is just a little bit bigger than 180. So I need to find out by how much. So theta r, all I'm going to do is just do 180 minus theta. And then I can just find that little piece that's bigger than 180. Now when I end up in the fourth quadrant, right, if I have an angle somewhere in the fourth quadrant, then all I need to do here is I need to find the distance between the x-axis, right, there's my x-axis, and the terminal side. So I need to find this distance right here. You can see that that both theta and theta r are going to equal to 360 degrees, right? All together, that's 360. So to find theta r, all I'm going to do is I'm going to take 360 and I'm going to subtract it from theta. So there are our rules for reference angles in all four quadrants. Let's go ahead and look at some examples now. So let me go ahead and erase this now that we have an idea of what we're doing. I'll leave the rules up there. Let's see, it says find the reference angle of 73 degrees. So let's do that. So 73 degrees. 73 degrees is in the first quadrant. So 73 degrees is here in the first quadrant. This is a very easy example because we know that the reference angle is equal to whatever angle we have when it's in the first quadrant. So done. 73 degrees. So let's write it up here. Theta r equals to 73 degrees. Let's look at the next one. The next one says 480 degrees. So 480, well, first of all, 480 goes around the unit circle once, right, and then a little bit more. So what I'm going to do is I'm going to find a coterminal angle to 480. I'm going to subtract 360 from it. And this is going to give me 120. So I know that this angle, I know that 480 is going to be the exact same thing as 120, right? It is exactly equal to 120. So here's this angle right here. Now I want to find the reference angle, which is going to be the distance from the x-axis to that terminal side. So I want to find this piece right here. So if I'm in the second quadrant, I'm just going to use my formula, which is going to be 180 minus 120. And I get a measure of 60 degrees. So now I know that this measure right in here is going to be 60 degrees. So that's my reference angle. So now I know that for 480, my reference angle is going to be 60 degrees. Let's do one more. It says negative 215. So negative 215 degrees. Let's go ahead and erase this. We're going in the negative direction, so negative 90, negative 180. It's not bigger than negative 270, so I've got to be somewhere in this quadrant. So this is negative 215. So I want to find the distance from the x-axis to that angle. Now this is where having a good understanding of this is going to help you out, because if you were just to follow the formula blindly, 180 minus your angle, then you would end up with a bigger negative, and we know that a reference angle has to be less than 90 degrees. So what we're going to do is we're just going to find the difference between those. I'm just going to take 215 and I'm just going to subtract it from 180, right? All I'm going to do is find the difference between them, and that is going to give me 20 and 15. That's going to give me 35 degrees. So that's going to be my reference angle, 35 degrees. Another way to do it is you can find the coterminal angle, the positive coterminal angle, and then subtract it from 180 that way. So now we know that the reference angle for 215 is going to be 35 degrees. So let's look at some radian reference angles. So what we're going to do is we're going to write down the rules all over again, but now we're just going to write them down in terms of radians. So the first quadrant is still the same. Your reference angle is still equal to whatever angle is in the first quadrant. In the second quadrant, now we're going to take whatever theta is and we're going to subtract it from pi. Whoops, let's go the other way around. Sorry, so this is going to be pi, and I'm going to subtract theta from it. Now if I end up in the third quadrant, then I know that I'm going to take theta this time and I'm going to subtract pi from it. It's exactly like the formula up above with degrees, except now I'm just replacing the angles in degrees with radians. And then the last one we have, instead of 360, it's going to be 2 pi, and then minus your angle theta. So let's look at some examples here. I haven't written any, so I'm just going to make some up. Let's say we have 2 pi over 3, and let's do 11 pi over 6. Okay, so let's go ahead and graph 2 pi over 3. So 2 pi over 3, right? This is 0. This is pi over 2, or 1/2. I know that 2/3 is greater than 1/2. And over here is 1 pi, but I know that 2/3 is less than 1 pi. So 2 pi over 3 is going to be somewhere in the second quadrant. So now I'm looking for the reference angle. I'm looking for the measurement between the x-axis and that angle. So I'm going to take pi and just subtract it from 2 pi over 3. So I'm going to have pi minus 2 pi over 3. And then we're just going to get our common denominators by multiplying the top and the bottom by 3. So I end up with 3 pi over 3 minus 2 pi over 3. And that ends up yielding pi over 3, which is less, 1/3 is less than 1/2. So I know that this is correct. So that's my reference angle. All right, perfect. Let's look at another one. 11 pi over 6. So 11 pi over 6 is going to end up somewhere in the, let's see. So this is 11 over 6. Oops. 11 over 6 is definitely greater than 1/2. 11 over 6 is greater than 1. 11 over 6 is greater than 3 over 2, but it's not, 11 over 6 is not quite bigger than 2 pi. So this is my angle 11 pi over 6. So now I want to find the reference angle. I want to find the measurement between the x-axis and the terminal side. So this is the angle I want to find. If I'm in the fourth quadrant, I'm going to go ahead and just use my rule. I'm going to take 2 pi and subtract that from theta. So let's go off to the side. Let's take 2 pi. I'm going to do minus 11 pi over 6. Let's get our like term. Let's get our common denominators, multiply the top and the bottom by 6. I get 12 pi over 6 minus 11 pi over 6, which is just going to give me pi over 6. Alrighty, and we'll be finding patterns out when it comes to reference angles in radians. You can kind of already see the pattern that you just kind of ignore the number on the top, right? We end up with just pi over 6. So that'll be kind of a faster way to do it, but we'll see that more next week.